Hey everyone, I'm Rongji, and in this quick tutorial, I'm going to show you a powerful new feature on the M9484C VXG signal generator called real-time channel fading. Whether you are working on 5G radio or satellite, this feature makes it super easy to emulate the real-time fading conditions, both standard and custom. So let's jump right in. Here's the agenda. We'll cover a quick look at the fading product portfolio and then followed by the live demo, how to run built-in 3GPP MIMO fading model, and then we'll cover how to apply a custom fading model using Channel Studio. The real-time fading feature runs on VXG-C with firmware 8.17 or later, and now is available through the PWSG embedded app. You will need one of these licenses here, N9604A for the standard 3GPP fading model, N705APPC for custom fading model generated by Channel Studio. Let's start with a 1x2 MIMO fading setup using the embedded 3GPP model here. According to 3GPP release 18, we'll simulate an uplink PWSG Type A signal at 100 MHz, 30 kHz subcarrier spacing, and use TDL B100-400 low fading model here with SNR -2.2 dB. Based on the FRC FR1A314 here. Step 1. Set up MIMO channels. First, let's set up MIMO on the VXG. On the PWSG app, click on the hamburger menu here, Config Channels. Choose N/2 MIMO, then click Apply. Now both IF channels are grouped and ready. Set your desired frequency and power level for each. Step 2. Generate the 5G radio signal. Next, we generate our 5G NR signal by using embedded 5G NR applications here. Choose the embedded 5G NR signal generation application here. Set the carrier to uplink, then go to the FRC tab. For FR1 at 100 MHz, select FRC 8.3, and then select A314 as a reference channel. The app auto sets the resource allocations for you. Once ready, hit Generate, and you will see your waveform show up with a green arrow. You can check the sample rate in the Waveform tab here. Step 3. Apply the 3GPP fading model. Let's go back to the home screen and click on the fader block. Set MIMO order to 1x2. Choose standard as 5G radio. Select TDL B100. The 400 Doppler and low correlation matrix settings will autofill. To mirror the configuration to the second signal path, let's hit Copy Node to all nodes. Then enable the fading block. You will see a blue fading icon. Fading is now alive. Step 4. Set SNR to -2.2 dB. Let's go back to the adjustment block. Click on AWGN tab. Here, enable flat noise and set SNR ratio to -2.2 dB here. This step simulates real-world noisy conditions. For demo purpose, I will disable it. Step 5. Verify with XApps. Now let's validate this signal using the XApps. So let's turn on IF port and set output to -20 dBm here. Let's switch to UXA screen. You will see the 5G NR uplink FRC signal demodulate correctly. Now apply fading to the second IF path. Over the VXG screen, notice that how sync is lost and the spectrum starts showing Doppler ripples. Let's switch back to VXG-C and turn on pass-through mode. Just like that, the signal is clean and demodulated again. Now let's see how to create and apply your custom fading model using Channel Studio. In the past, with version 1.1, you had to manually import the model to the VXG-C. But with the latest version 2.0, it's much easier. Just click Download button and the model file will be generated and sent straight to the connected VXG-C. Super convenient. If you haven't upgraded it, I highly recommend it. Alright, let's dive in. Step 1. Load a CW signal. Let's go back on the VXG screen. Set your frequency and test power first. Now let's go to the signals block. Click on the waveform tab. Click select button here. Then choose a CW waveform you've prepared before. Let's enable it in the general tab. You can see the green icon here means it's active. Step 2, let's launch Channel Studio. Let's go back to the fader block and select MIMO auto one by one. Let's select standard as custom. Before importing a model here, let's launch Channel Studio by click on hamburger menu and click on the switch to Windows here. Inside the Channel Studio software, you can start a new project or open an existing one. Here, I've loaded a project with 3 fading paths. The TDL tool lets you build different models, like relay, racing, or jacks for Doppler effects. Click View Spectrum here to check the power delay profile and Doppler spectrum on the right-hand side. In this case, it's plus and minus 500 Hz Doppler with 3 delay paths here. Step 3. Download and apply the fading model. So let's go back in the Channel Studio. If you are using version 2.0, click on the Preferences button in the pop-up page, enter your VXG-C IP address and click OK. Then just click Download. This sends the fading model directly to the VXG-C. Now let's jump back to the VXG-C screen. Click Select, and you'll see the new model profile has already been imported here. Select it, hit Select, and you are good to go. Turn on the fading block. I will keep it in pass-through mode for now. Let's go back to the home page. The blue fading icon on the signal block confirms it's active. Step 4. Verify the signal on VXG. Now let's go back to the VXG screen and enable the IF port and the fading on the second pass. Let's switch to the UX side. The CW signal now shows real-time fading effects. Check the spectrum here. It should match what you configured in the Channel Studio. Here is approximately 1 kHz spectrum spread. This caused by the plus and minus 500 Hz Doppler. And that's it. Real-time channel fading, standard 3GPP, or fully customized or integrated right in the VXG now. To learn more and grab a free trial, just head to our website and search N9605. You will find everything you need to get started with PWSG embedded application for the channel fading. Thanks for watching.